Welcome to another episode of Terry's Notes. Today we're going to be looking at bonding. Specifically, we're going to look at ionic bonding and covalent bonding. Let's start with ionic bonding. Now, an ionic bond is formed between a metal and a non-metal. So the example we're going to use is sodium chloride, which is NaCl. Sodium is in group 1 and it has an electronic configuration of 281. There are 11 protons and 11 electrons. Therefore, the sodium atom is uncharged because we have an equal amount of positive and negative charge. Remember that protons are positively charged and electrons are negatively charged. So if they are equal, it means that the sodium atom is uncharged or neutral. It has one valence shell electron, meaning that it has one electron in its outer shell. That is this one. In order to achieve a stable structure, and anytime we refer to a stable structure, we are talking about a noble gas structure. So a structure like 2, 8 or 2, 8, 8, and these are the electronic configurations for some of the noble gases. Remember that the noble gases are very stable. So in order for sodium to achieve a stable structure, it must lose its valence shell electron in order to form the sodium ion. So this electron is lost in the process of forming an ionic bond. There are 11 protons and 10 electrons. So if the sodium atom were to lose this one electron, what will happen is that you will now have 11 protons inside the nucleus. See, 11 protons. And we now have 10 electrons around the nucleus. So therefore we have more positive charge than negative charge. So since there's one more proton than the number of electrons, the sodium ion has a +1 charge. The electronic configuration of the sodium ion now becomes 2,8. Therefore, it is now a stable structure. So let's look at chlorine now. Chlorine is in group 7 and has an electronic configuration of 287. There are 17 protons and 17 electrons. Therefore, the chloride atom is uncharged because we have an equal amount of positive charge and an equal amount of negative charge. It has 7 valence shell electrons. Now remember we said that you need, in order to become stable, you must end up with an electronic configuration like one of the noble gases. So in the case of the chlorine atom, in order to achieve a stable structure, it must gain one valence shell electron to form the chloride ion. Because remember, we have 7 in the outer shell. So if we get one more electron, it'll become 288. And the chlorine will become more stable. So it gains an electron from the valence shell of the sodium atom when a bond is formed. There are 17 protons and 18 electrons. So therefore there is one more electron than the number of protons, and the chloride ion has a negative charge. The electronic configuration of the chloride ion is 288. So just to show you what is happening here, we have the sodium atom, we have the chlorine atom. The electronic configuration of the sodium atom is 281 and the chlorine atom is 287. In order for sodium to become stable, it has to lose this electron. And in order for the chlorine atom to become stable, it has to gain one electron. So what we are saying is that this outer electron moves from here to here. And in so doing, we end up with the sodium ion. So we have, this represents the sodium ion, and this represents the chloride ion. So you have an Na plus and you have Cl minus. As you can see, they are both oppositely charged, and therefore they will attract each other and they will form an ionic bond between the sodium ion and the chloride ion. The sodium ion is positively charged and the chloride ion is negatively charged. They attract each other by electrostatic attraction. The bond formed between the two is called an ionic bond. It is important to know that this bond is very strong and affects the physical properties of sodium chloride. So these are just some of the physical properties of sodium chloride. One, it has a high melting point, and it has a high melting point because of the strong electrostatic forces of attraction that exist between the sodium and the chloride ions. It requires a lot of energy to separate these ions, and that is why the melting point is high. Second physical property is that it is soluble in water. We would recall that water is a polar solvent. In a water molecule, there are 2 hydrogen atoms and 1 oxygen atom. The oxygen is more electronegative than hydrogen. The electron pair in the OH bond is pulled closer to the oxygen atom. The result is a partial negative charge on the oxygen atom and a partial positive charge on the hydrogen atom. And this makes the water molecule a polar solvent. So if we were to draw a water molecule, what we are saying is that oxygen is more electronegative than hydrogen. So the electrons in this bond here, they move towards the oxygen. And what happens is that you get a partial negative charge on the oxygen atom and a partial positive charge on the hydrogen atom. And this is why water is a polar solvent. So when sodium chloride is added to water, the oxygen atoms from the water molecules move towards the sodium ions. The hydrogen atoms from the water molecules move towards the chloride ions. And therefore sodium chloride dissolves in water. The third physical property is that sodium chloride is a solid at room temperature and does not conduct electricity. The ions present are not mobile, and that is why it cannot conduct electricity. When sodium chloride is in a molten state, it conducts electricity because the ions become mobile. And when sodium chloride dissolves in water, it also conducts electricity because the ions become mobile. Just remember that when we speak about an electric current, we are speaking about the flow of electrons or the flow of ions. So once we have ions moving, we have an electric current present. So sodium chloride in its at room temperature is a solid, and even though you have sodium ions and chloride ions present, they are not moving, and therefore they cannot conduct electricity. Now let's look at covalent bonding. Covalent bonds are formed between atoms that cannot form a stable electronic structure by gaining or losing electrons. As in the case of ionic bonding, we have the metal losing electrons and we have the non-metal gaining electrons. But in the case of a covalent bond, the atoms are not able to form a stable structure by doing that. So in order to achieve a stable structure like a noble gas, these atoms share one or more electrons with other atoms. In a simple covalent bond between two atoms, each atom contributes one or more electrons to the bond. So let us look at some examples. Take for example hydrogen chloride gas. Now hydrogen has one electron in its shell, and the outer shell or the valence shell of chlorine has 7 electrons. So in order for chlorine to become stable, it needs to have 8 electrons in its valence shell. So what it does in the case of hydrogen chloride is that the hydrogen atom and the chloride atom share 1 electron each. And what happens is that you get a covalent bond. So this here represents a covalent right? Let's look at ammonia gas. Now, ammonia gas is is NH3. So we have one nitrogen atom and 3 hydrogen atoms. Now nitrogen is in group 5, so we have 1, 2, 3, 4, 5 electrons in its outer shell, and we know hydrogen just has 1. So in order for nitrogen to form a stable electronic structure, it needs to have an additional 3 electrons, and these electrons are provided by each of these 3 hydrogen atoms. So what happens is that we get 1, 2, 3 covalent bonds being formed. So you may see nitrogen being represented by a structure like this. Right? These 2 electrons don't take part in bonding. The next example we're going to look at is methane gas, and methane is CH4, and carbon has 4 electrons in its outer shell. So what it needs to do, it needs to share 4 electrons with 4 electrons from the 4 hydrogen atoms. So what happens is that we end up with 1, 2, 3, 4, 5, 6, 7, 8, and methane looks something like this. The next example we will look at is oxygen gas, and oxygen is really O2. So we have 2 oxygen atoms here. Just draw oxygen, and oxygen is in group 6, so it has 1, 2, 3, 4, 5, 6 electrons in its outer shell. And what it does is that each oxygen atom will share 1 electron each. So what we end up with is two oxygen atoms with a double bond between them. In the case of nitrogen, nitrogen is in group 5, so it has 5 electrons in its outer shell. So if we have 2 nitrogen atoms here, what happens is that each nitrogen atom will contribute 3 electrons to the bond, and what will happen is we will end up with a triple bond. Now let us compare ionic and simple covalent compounds. So the first property, in terms of composition, in a simple covalent compound, you have molecules present, and within the molecules themselves you have strong covalent bonds. But what happens is that you have weak forces between the molecules. Right? Now this is a key thing that you need to remember here. Always remember, covalent bonds are strong. What is weak is the forces between the molecules. And in the case of ionic compounds, we have ions present, and we have strong ionic bonds being present. The second physical property is that simple covalent compounds are either liquids or gases at room temperature. In the case of ionic compounds, they are crystalline solids. If we compare melting point and boiling point, simple covalent compounds have low melting point and they have low boiling points. And the reason for this is that we have weak forces between the molecules. These weak forces are referred to as van der Waals forces. And because these forces are weak, a small amount of energy is required to overcome these weak forces. And that is the reason why simple covalent compounds have low melting point and low boiling points. In the case of ionic compounds, they have high melting points and high boiling points. The reason for this is that the strong electrostatic forces between the ions. We have strong electrostatic forces between the ions, and a large amount of energy is required to separate these ions. And this is why ionic compounds have high melting and high boiling points. If we compare solubility, simple covalent compounds are usually insoluble in water. They are soluble in organic solvents like tetrachloromethane or ethanol, right? Now, in the case of ionic compounds, they tend to be soluble in water, and they are usually insoluble in organic solvents. When we compare electrical conductivity, simple covalent compounds typically do not conduct electricity in any state because there are no free electrons present or ions present. In the case of ionic compounds, they do not conduct electricity in the solid state. However, if you melt it or you dissolve it in water, the ions become mobile and therefore they are able to conduct electricity. So, how do we know what type of bond will form between atoms? As a general rule, metals and non-metals tend to form ionic bonds. For example, sodium is in group 1 and chlorine is in group 7. When they combine, they form an ionic compound called sodium chloride. Magnesium is in group 2. Oxygen is in group 6. When they combine, they form magnesium oxide, which is ionic. Aluminum is in group 3 and oxygen is in group 6. When they combine, they form aluminum oxide, and the bond in here is ionic. Sodium is in group 1, oxygen is in group 6. When these two react, they form sodium oxide, which is also ionic. So generally, a metal and a non-metal will form an ionic bond. Non-metals tend to form covalent bonds. For example, nitrogen is in group 5, and two nitrogen atoms are able to combine with each other to form a covalent bond to form the N2 molecule. Oxygen is in group 6, and two oxygen atoms are able to combine using a covalent bond to form the oxygen molecule. Chlorine is in group 7, and two chlorine atoms can combine to form a chlorine molecule, which is Cl2. Methane is in group 4, and it is able to form a covalent bond with hydrogen atoms to form methane, which is CH4. Oh, sorry, I said that wrong. Methane is made up of carbon and hydrogen. And carbon is in group 4, and hydrogen, this is a mistake, this should be 1. Hydrogen is in group 1, and they can form covalent bonds with each other to form methane. In the case of ammonia, ammonia is made up of nitrogen and hydrogen. Nitrogen is in group 5 and hydrogen is in group 1, and it is able to form covalent bonds in this case as well. So non-metals tend to form covalent bonds.